All right, so for those of you who haven't heard of curl, curl is a fantastic tool. It's available to you in your Linux operating system. You can actually go into the interface, command line, and type the word curl. It is what it says. It is what it spells, C-U-R-L. And if you type in a path, or actually let's put in an IP here. Makes it a little bit more simple for the test you may be doing between your big IP and the backend server. So let's say I go to http://10.128.20.3 and I hit enter. I could put a path there if I wanted to. I hit enter. What's going to come back from this curl command is going to be the text output of what the server returns when you call that page. So it's basically doing a command line get and giving you the text output back from the server. So this tool not only tells you and confirms that your big IP platform can do the get string that you may have in your get field of the health monitor you have applied to the pool, by showing you that you're getting output back, but it can also help you confirm what you're monitoring. So if I know that my get string is path/index.html, and I have this in my get string of my health monitor, my receive string of the health monitor says here's what a successful return from the server would look like or contain is this text string. I can look into the body content that comes back from the server and pick out something to put into my receive string of that text output. So it actually gives me content to see what would be coming back from the server to put into my receive strings on my health monitors. Because how many times have we, as administrators, you know, we've got to configure up a virtual server for a new application. We've got to configure up the pool and get it load balancing. We need to do health monitoring, and we ask the app team, what do I health monitor on your servers? And they all say the same thing. I don't know, right? So what do? We actually can say, look, tell me where your users go. What path do they go to when they go to your application? And they say, oh, we know that, and they give you the path. And here's where all of our users go to get to the application. You could actually go to that path, use a curl command to get to it, see the output, and then bring this back to them and say, what on here doesn't change? What stays consistently the same? Right? And some applications have dynamic content, and there's things you have to fight with and have to figure out how to monitor. Maybe I need to have them build a custom health monitor page that we hit with our get strings and expect consistent receive strings back from them. But curl is a great way to see not only are things working, but what is coming back and what part of that could I use in my health monitors. It's a great tool. I know this representation is kind of dirty, but we could do a nice screenshot maybe for you if we have time. All right. These are some of the tools you have available to you for troubleshooting. Why is it going backwards? Okay, explain the difference between virtual server status definitions. So the definitions of our statuses that we talked about earlier when I walked you through them are enabled means that the virtual server is up and available and monitors are succeeding, and it's represented by a green circle icon. Offline means that the resource for the virtual server is not available, likely a failing monitor. It's represented by a red diamond. Currently unavailable means that the virtual server has a restricting connection limit. It has been reached, and it's represented by a yellow triangle icon. Unknown means that there's not any monitor set for the resource. So there's no monitor set. Status doesn't mean that the virtual server won't respond to traffic, because it will respond to traffic. It's just that right now the resources aren't known if they're online or not, and that's represented by a blue square. And disabled means that the administrator has marked that virtual server or resource down inside the configuration. And the status icon will be the shape that represents the current monitoring status, but will always be colored black because the administrator has marked it down. Discuss the effects of health monitors on the status of pool members and nodes. So as you apply health monitors to resources within the configuration, like nodes or pool members, that health monitor will immediately start checking to see if the resource is available or not available, depending on what you've assigned the monitor to. And if you've got members that are down, in this screenshot you see I have a pool, and I've gone in and I'm looking to see my availability of the pool members, and right now the pool is offline due to the children pool members being marked down by health monitors. If I looked inside the members tab of that same pool, I would see that both of my pool members are down. Their statuses are red diamonds. And that tells us what? That tells us that the monitors are failing, but we haven't marked them down as administrators. The monitors are just not succeeding. And that means they're not available at this point because we can't get to them in the way that you've said we need to be able to get to them. If I clicked into one of these members to look deeper into the configuration of that member, I would actually see that I have multiple monitors assigned to him, 2 health monitors. One is succeeding and one is failing. And more than likely in the configuration of this particular pool member, I have said that I'm going to configure multiple monitors, but all monitors must succeed for it to be marked up. If any monitor fails, it's going to get marked down. So in this case, even though my custom TCP monitor is succeeding, my custom HTTP monitor is failing. And some other great information on this particular page about this particular pool member is that the parent node, at an IP level, I'm actually doing a health check. I'm actually doing a ping to the IP, and that one is responding. I can see the status being reflected here. Even though I'm in the pool configuration for the member, I can see the parent node is actually up and working. So my custom HTTP monitor is what's causing this particular member to fail in the pool. And if I looked, probably on my other one, it's doing the exact same thing on .11 and .12 I have in this particular pool. Thus, since both of them are down, their status is marking the pool down. And if that pool is assigned to a virtual server, the status of the pool being down would be reflected at the virtual server level because the virtual server would be marked down as well. Determine the state availability of a pool member node in question. Another way to do that is to look at the network map. If I'm in the network map and I can see that I've got a pool member down, I can see if I have 1 down, 2 down, how many I have down, and then on top of that, if everything is down, my pool will be down, like I've said before, and if the pool member is down, if the pool is down as an object, the virtual server will be marked down as an object as well that's using it. Can you see the importance of actually being able to navigate the GUI and understand what you're looking at within the GUI? If I were given a screenshot of my virtual server list or of a network map and asked if somebody tried to connect to a certain IP address, would it work? Even though I have a listener built that could take it in, if it's not up, it can't take it in. It's down. So it may fall back to a different listener that is up, that matches by IP port combinations that are broader, like we talked about earlier today in our listeners. So understanding how to look at a GUI and take in what information it's giving to you will help with screenshots that you may be looking at during the exam. It's good to get some exposure. All right. I can also go in and show my pool statuses at command line. As you can see here, I've got a show LTM pool, the name of the pool, and members all, show me all members. And this output is huge, right? It's going to have not only statistics and status of the pool itself and statistics about the pool itself, but for each member it's going to have all the configuration and statistics on them. I did a screenshot and just cut the top part of this pool, giving you the pool status and the very top of the first member of the pool on the list, instead of doing all of them, even though the output was for all. You should be able to identify the reason for an unresponsive pool member by verifying things like the pool member node ratio configuration. So when we talked about load balancing algorithms yesterday and how they work and the different ones we have available to us and when we may use them or not use them in the 101 section, we actually have the ability to configure up how that works within each pool configuration. So if we looked at how a pool member is configured as we go through configuring out the pool, we give the pool a name. We could sign our health monitors here at the pool level. If I'm in advanced, you're going to see that I can do some deeper triggerings around how we want to do health monitors. If I'm in the resource section and I choose a load balancing algorithm like ratio, ratio for us is, I talked a little bit about this yesterday. Ratio for us is actually a way of distributing that connection load across the different servers on the back end based on assigning a weighted number to each member of the pool. And in this case, we get into the fact that if I choose round robin here, the GUI is very intuitive in that it says, well, if I'm choosing round robin, I don't need a ratio weight, so I'm not going to show you the ratio field. However, when I use ratio as my algorithm, it's going to give me a visual on the ratio weight field because I've chosen to use it. So there it is for me to enter it in when I'm building that new pool. So it's a little bit dynamic in flow. If I had chosen priority group activation, it actually would have expanded out and given me a way to set the different settings for priority group activation and add the value in for the priority group to the member. But because it's disabled, it's not showing it to me. So the GUI will only show you really what you need to see or what you've asked to see as far as the settings you're choosing. But in this case, if I want to verify a pool member's ratio configuration, if I've configured my pool to use ratio, the field will be there. I can add the value and then add the member to the group and then finish building my pool. And what that would look like is, let me click back a little bit. What it would look like is right here. Sorry, one more time. I can see that I've got two pool members and they've been assigned a ratio value. You can also see the fields where there's priority group activation values and connection limit values in this same field on the members tab of the pool. So let me jump back to where we were. Another value they want us to be able to recognize is the connection limits on a pool member. So if I go into my pool list and I'm looking at my pool list and I've chosen now weighted least connections, notice that now that ratio field is not being shown, but the weighted least connections field or the connection limit field is being shown. So now I can put in that connection limit of 100 or 200 or 1,000 or whatever I feel like the correct value is here and add that as I add each member into the pool. Now, one of the things that none of the bullet points talk about is priority group activation. I've heard, I think, from one of the students that they ran into a priority group activation question on the exam. And because I've heard that, I tend to cover it in every class, even though it's really not a part of the blueprint. So we're going to go to the board real quick and talk about priority group activation. All right, for priority group activation, I usually like to tell most of the students in my classes how it works around an example. The basic layout or configuration of a priority group within a pool would be that I could give, let's say I have 6 members in my pool. Hopefully these boxes come up nice and dark for you. So I've got 6 servers in my pool that I could distribute traffic across. As I added each member to the pool, I give them a priority group number. And so that priority group number can be any number I want to assign. It's not specific or it's not really random, but it's not specific either. I use it as an administrator to configure how I want traffic to flow to these boxes. When priority group activation is enabled, what it's going to do is it's going to activate the highest priority group number first. And when that priority group number gets activated, all the members of a pool or all the nodes that are associated to that number on that highest number that it activates, if it meets its minimum, or at least number is what they call it, when it meets the at least number that we have configured in priority group settings, then that would be the only group it would activate. If they activate the first group and it still doesn't meet the minimum of members that has to be up for the priority group to work, it'll activate the next lowest number priority group. And if that added on to the first group then meets the minimum, then it stops activating groups. But if that one still didn't, it would keep activating groups until it meets that minimum number of servers that are required. So let's say in this, I have 6 servers available to be load balanced within my pool, and I want to turn on priority group activation, and I'm going to set it to at least 3. At least 3 members, and that usually is a field in the priority group. And as I assign the members to this pool, I gave each one of these guys a number. So I gave this one a 10 as a priority group number. I gave this one a 9, an 8, a 7, 6, and a 5. And so because priority group activation was turned on, he activated the highest priority group, and that was this one server. And he said, okay, I've activated one server, I need at least 3, this doesn't meet the minimum of having 3, so he activates the next lowest number. Now that number comes online, I've now got 2 servers, I still don't meet 3, I activate the next group, I now have 3 servers online, I've met my minimum of 3, and I no longer activate servers for active use within the pool. What does that mean? That means as connections are coming into the virtual server and being sent to the pool to have the best server chosen, it's only going to look at the active servers that are actively being used in the priority group to distribute connections across. So it starts sending the load balanced algorithm. Let's say our algorithm is round robin. It goes to this server, then this server, then this server, then this server, then this server, and this server. And what priority group activation does is it says only use these 3 servers basically until one of them dies. If this guy dies, our health monitors stop working, we mark it down. Something's happened on the server, we don't know exactly what. Priority group activation will immediately look to see if there's another group, and there's 3 other groups. It'll activate the next lowest number, which is 7. This guy will now come online, and load balancing will now start going to these 3 because we've met our minimum of 3 just by activating the next server in the next priority group down. So now as load balancing is happening, it's going across 10, 9, and then 7, 10, 9, 7, 10, 9, 7. If later on I figure out that 8 had a problem when we get it working again, and this guy comes back online, I no longer need 7 to meet my minimum of 3, so I'll deactivate 7 and take him out of the pool flow, and the round robin algorithm will go back to going 10, 9, 8, 10, 9, 8, but if any current connections were still connected to 7, he doesn't kill them. He lets them continue and slowly wean out and drop off gracefully, right? And so if I lost 8, again, I would activate 7, and then if I lost 9, I would activate 6. Or if I lost 8 and then I lost 10, I would activate 7 and 6 just to have 3 going at any given time because my least minimum there is 3. So this explains the function of how priority group activation can bring servers online. And it's up to you as the administrator to set your priority groups. If I had priority grouping set and I said each of these are 10, this one is 9 and this one is 8. If I configured it in this manner and I activated the first highest priority group and all 3 of these servers would come online because they're in the first group and it met my minimum of 10, I wouldn't activate any more groups because I have 3 servers working. But then if I lost this server, I would activate 9, and actually now I would have 4 servers working because one of these guys went down, right? And if I lost another server, I would still have 3 up, so I wouldn't activate another group. But then if I lost this guy, I would actually activate 8 because I need 3, and now I have 3 again, and 3 would be working. So it's up to you to build the priority group how you feel you need to do it, and this is how it works. The question I get from most students is, what business problem does this solve? Other than, if I've got 6 servers I could use, why aren't I just using all 6 servers? Why would I just use 3 out of the 6? What we can say is in IT, a lot of things happen in projects, right? And as projects are being developed out and budgeting is happening, companies will say, okay, we've got a new application coming along, it's application A. Application A, we're going to buy it 3 servers so it can load balance itself across those 3 servers. It needs 3 servers for resources, and they purchase 3 servers. And then app team B comes along, and they're going to build out their new application B, and they are going to get 3 servers as well. And those 2 servers are all 6 servers that we just purchased are all Windows servers. And the 2 applications running on their individual 3 servers are actually all Microsoft Windows-based applications. So they can all run friendly together, right? What we tell them is install application A and B across all of the 6 servers that we have. Because applications can live friendly together. It's not NT anymore, right? Back when DLLs would step on each other and everything was a nightmare. Apps can live friendly together on servers these days. And so B bought their 3 servers and A bought their 3 servers. But when I build out the pool for application A, I'm going to put all 6 servers in it. And I'm going to make these 3 servers priority group 10. Why? So that app A is always using its 3 servers all the time primarily. And if anything were to fail or go wrong, I'll bring on at B servers as failures might happen within the data center. And when I configure B's pool, I do just the opposite. I configure all 6 servers, but I put the higher priority group on B's servers that they purchased. And then on the servers that A would use, I build a priority group like this for the B pool. And now what that does is it lets B use their resource primarily, but they could fail into A. And A uses their resource primarily, and they could fail into B. Kind of cool stuff, right? But this is priority group activation, how it works, and then an example of how businesses may use it to their advantage within the data center for failover. All right, objective 1.4, or 04, says identify a persistence issue. The first thing they want us to do is explain the concept of persistence. Now, we talked a little bit about basic persistence concepts in the 101, so everybody should be a little bit familiar at this point with what persistence is. But we're going to rehash a little bit and say that persistence is needed because applications can't handle 100% of distribution of load across multiple servers all the time. Sometimes applications require that once a user gets put on a server, that user remains connected to that server for the life of their session for whatever reasons. And it could be reasons around session state information being stored locally on that server. Authentication happened locally on that server, and if we move to a different server, we've got to re-authenticate. Things of that nature that keep the application from being able to be load balanced across any server in the pool at any given time. Now, that doesn't mean that we're not load balancing when we talk about persistence, because if you were asked the question like, we have persistence turned on, do you load balance? The answer would be yes, because the very first inbound connection from that user that's never been seen before gets load balanced to the best server in the pool. But once it's connected to that server, persistence will keep him there or her there for the rest of their session. So thus, it doesn't allow us to continue to load balance throughout all the things they do on their application. I've said this before, persistence is the nemesis of load balancing, right? It is what we don't want to do the most, right? But sometimes it's required of a big IP platform or a network load balancer to keep a user tied to a server simply due to the fact that the application requires it. So if you need to verify what type of persistence is being used in the configuration of an application's virtual server, there are a couple of different ways to go in and take a look at that. You can actually go into your virtual server, click on the details, drill down into the virtual server, and look at the Resources tab if it's an existing virtual server. And on the Resources tab inside the GUI, you'll be able to see the default persistence profile here. And in this case, this screenshot has actually got the Dropbox for fallback expanded, but as you can see in the default persistence profile, I'm actually using cookie persistence. Now, there are different types of persistence that we can use, and we discussed all those back in the 101 at a high level. But if you needed to verify if we're even doing persistence, this is where if this is turned on and not set to none, it means we are doing persistence, and it tells us what type. And if you wanted to then go look at the type we have defined and see how it's set up to be used or works, you could go back into your profile section and go to your persistence section and drill in and find the profile called cookie in this case, and look at the settings inside that profile to tell how we are persisting as far as cookie persistence is concerned. You may have a custom name here where you've made a custom persistence profile, and that's what's in the drop-down box. But this is one of the ways to verify the type of persistence that's assigned to the virtual server in question. How do we validate the expected type of persistence? I think one of the easiest ways for most administrators to validate persistence is once they've built the virtual server, especially if it's an application like a website or something to that effect, they could easily connect to it themselves and then look in and see if their sessions are being persisted and if it's behaving like you would expect as a user to be stuck to one server for the entire length of the session. Sometimes the administrators don't have the ability to hit an application and then log on because they don't have an account. So we need other ways of doing it, and you can actually sometimes work with your development teams to be able to have them connect, see that they're seeing what they expect, and if they say yes, it's behaving like we expect, or no, it's not, you could then dig in to see if the session is actually being moved around. by looking inside some of the different areas of the GUI, and we'll discuss those in a little bit. How do we differentiate between fallback and primary persistence? This is a big one. A lot of people don't understand the concept of how this works. I showed you the same screenshot a second ago where we've got cookie persistence defined, and in our fallback persistence profile, we may choose something that's IP address based as a fallback methodology. And in this case, let's say we chose source adder here as our fallback persistence. Now, we've talked about how cookie works at a high level, where if a user comes in and makes a connection to our web-based virtual server listing on port 80, he connects to gets load balanced to the back-end servers, and the back-end servers are hosting up data back to him to respond for the website. If we have cookie persistence turned on here, let's say the default one is our cookie insert, and it's session-based. We insert a cookie into the flow between the F5 and the client, back to the client's browser. So that cookie will be saved on that machine, on that client machine, and as he connects back in again for another call or the next session in, or next connection into the application, he'll pass that cookie back to us. And because we see the cookie and we know we're using cookie persistence and I see him giving me a cookie, I will read the cookie as the big IP platform and say, oh, he was on server 6 in our pool, and I'll load balance him, not load balance, I will reconnect him back to server 6 again like he was on before, without making a load balancing decision. But what would happen if I were using cookie, I inserted the cookie and gave it back to the client, but every time he came back in, the cookie wasn't present? Maybe his browser didn't accept cookies. Maybe he had his browser set to where I don't accept cookies. Now, likely, if his browser is set to not accept cookies, he's not doing much on the internet, right? Because almost everything requires cookies to function these days. However, if he was denying cookies and we were using cookie insert, there would be no method for us to see a cookie coming back and use that to get him back to the server he was on. We would reload balance him every time because we wouldn't see the cookie. So if we had a fallback persistence profile, it could help us with those users that may not accept cookies, as an example. How would it do that? Well, when I think of the word fallback, I think if one way doesn't work, we fall back to another way. But the actual behavior you're going to see here is that we're doing both simultaneously. We're saying insert a cookie and make a persistence record based on his source IP address. And then the next time he comes in, if he gives us a cookie, great, we use it. If he doesn't give us a cookie, we look to see if he matches one of our source IP records. Oh, he does. He was on server 6. We stick him back on server 6. If it's a net new user coming in, we've never seen him before, he's going to come in and not have a cookie. I'm still going to check to see if his IP matches one of my source records. He shouldn't, if he's never been in before, match one of my source records. And then I would load balance him on that first call. On the way back, I would make the source record and I would give him a cookie. And then as he comes back in, hopefully he's giving us the cookie. We read the cookie and put him on the server he was on. If he doesn't give us the cookie back, we can fall back to that record we made. However, this can kind of bite us, right? You've got to think about that behavior. If I'm doing both simultaneously and this fallback persistence method I choose is source adder based, but I built a custom one that's got a broader network mask for the source IPs. Instead of being a set to none, or I think it's actually default, the default settings behave like a 32-bit mask. So each individual user gets their own record. If I built a custom one that was maybe a 24-bit mask, and those users were coming in from a corporation that is snatting or padding everything on the way outbound from their company, as that traffic leaves their company, they're all coming from the same IP or same range of IPs that probably fall within a 24-bit mask of each other. And when Bob came in first in the morning, he came in and connected, had never seen him before. I load balanced him to server 6. I made a record of his source IP address on a 24-bit mask, because that's the type of source adder fallback I used. And I gave him a cookie on the return, right? So as he comes in again, everything will work for him. But as Susie leaves that same company coming into the big IP, I've never seen her before. She's a net new user. She doesn't have a cookie for me to use, but I look at my fallbacks and I see that 24-bit mask she's coming from was on server 6. So I put her on server 6 and then I give her a cookie on the way back. Technically, I didn't load balance her and I've never seen her before, right? So when you're using a fallback persistence profile, they're going to be typically address-based. And when they are, you've got to make sure that when you're building this, you probably want to build it with a 32-bit mask, or basically use the default type of profile, because that is based on a 32-bit mask. here as well. Use the appropriate tool to troubleshoot persistence. I find this one kind of interesting. There's a lot of different ways inside the Big IP platform to go look at our existing persistence records. However, if we're using cookie-based persistence, there is no record on the local machine on the Big IP platform of the cookie itself. That is something that's happening in flow. So as the response goes back to the user, we're sticking the cookie into the HTTP headers. It's in flow to the client, and then the client returns the cookie to us. So locally on the machine, I'm not keeping a written record of the cookie. But if it's a source IP-based record, I'm keeping an IP record that says user's IP was load balanced to server 6 and pool 1 IP address. And so that record table is there for those types of records. So if I want to go troubleshoot persistence and I want to see if there's a record on the local machine, a local Big IP, of the persistence record, I could actually now, I don't have to go to command line just to do this anymore. We've had the availability in the GUI for a while to go into statistics, which this is probably a good time to bring it up. Probably should have brought it up before. This test is based on 11.1. Okay, so what some of my screenshots have been from so far have been 11.4. And I did them right here out of my VLabs box that I was running when I did the screenshots on this. And so the only real thing that's changed as far as navigation, there's only one or two things that have changed. And one of them is that in the main tab, the top section is now called Statistics in the newer version. It used to be called Overview here. So whenever you see a question on the exam, it's going to be based on 11.1. So what I will like to say to everyone is when you're building out your VLabs and you're going to study for this exam, download the 11.1 VE. Use your 45-day temp key that I give you for the 11.1 image. Study for the exam based on 11.1 so that you get a feel for when they mention a path to you, like overview statistics, you're familiar with what they're talking about, because if you're using 11.5, because it's the latest, it's not going to be the same. It's going to be statistics, module statistics. But it looks and feels the same over here for the most part. It's just that some of the menu names changed from 11.1 to 11.4 and 5. What you're going to go into once you're in statistics is you're going to go into statistics type, choose persistence records, and it's going to show you all of the persistence records on the local machine. You can also do this at command line by doing show LTM persistent records, or persist records, as the command, and it'll show you the same exact table that you would see in the GUI. Troubleshooting persistence can be a little tricky, right? Because if we're using cookies, I've got to go try to dig the cookie up by looking at the browsers, see where the browser stores its cookies, see if my cookie's there. It could be a user-side issue when it comes to cookies. They could have cookies disabled. It could be that I'm using source adder on this side, but one of the problems I'm having is all of my users are coming in from the same IP address because they're being proxied out to one IP. They're being snatted or padded out to a single IP address on the outbound from their company. Or maybe it's something like AOL, right? I've got a mega proxy out there, and they've got blocks of IP addresses that all users using AOL come from when they make their calls out. That type of environment can actually cause us to have problems with how we expect persistence to behave within the configuration of the Big IP. We may think we have it completely configured correctly, it's just not behaving the way we want it to. Then we've got to take a step back and look at our architectural environment and say, how is everything happening, and can we do it a little better? When you're in those mega proxy or padded outbound scenarios, we want to try to use cookies as much as possible, but sometimes the traffic we're load balancing isn't web-based. There's no way to stick HTTP header cookie into an HTTP header when there is no HTTP headers because it's not HTTP-based traffic.